So very good day to everybody once again. So this is internet programming and we are going to deal with the first topic, which is nothing but web essentials. In the world of internetworking, client, server and communication is very important. For example, server is going to provide connection to the client. You take in the case of Mobius, you take in the case of user. Okay, the operator is giving service to the user and you are enjoying the services as a client. Similarly, from the client, from the main system, the service is being spread across different systems, across different clients, and communication has been established. Okay, so this is what we are going to discuss in today's class, and this is especially for you, my dear students and young researchers, and you can reach me at dr.christoananth@gmail.com. So before beginning any session, don't ever forget to thank God. Okay, because of God we are alive. Okay, so for this I thank God for giving me this golden opportunity to deliver this useful session, to share my knowledge among my fellow national, international participants, students and young researchers. So in today's session we will have a short introduction to the internet, then we discuss about NSF network, then we discuss about the IP function. What is IP? IP. Very good. Internet protocol. Okay. So the function we would be establishing, port numbers, different port numbers we would be explaining, then UDP, user datagram protocol, that we would be discussing, DNS, domain name service or domain name system, that we would be discussing. Then we discuss about the higher level protocols. Okay, for example, in the network you would have heard about application layer, transport layer, network layer. So all other high level protocols we would be discussing. Then we discuss about www, World Wide Web. Then we discuss about the browser server interaction. For example, if you are typing www.google.com, it is not loading. Then you will get, what is the system? Network is not connecting. You will complain. Okay. So that browser server interaction that we would be discussing. Then we discuss about URI, Uniform Resource Identifier. We discuss about the common header fields. Finally, we end this class with the client caching. Okay. So I have some independent work also. Give me some time. I will create the Google Classroom. You will all join, and of course you will submit your independent work and the open-ended project work. Okay. And at regular intervals, I'll be showing you some short videos to discuss the knowledge in our topic. Fine. So this is how internet has evolved. It all started with ARPANET. ARPANET is nothing but Advanced Research Project Agency Network. From there only came internet. So back in 1960 it was established, ARPANET. So we had not homogeneous, not within that, heterogeneous network which are geographically located. Okay, for example, from here to the nearby region. Okay, the connection has been established. So in 1972 the first email was sent. For example, you use Gmail, you use Hotmail, you use Yahoo Mail. Okay, back in 1972 the first email was established, and ARPANET generally it was limited to the DoD, Department of Defense funded organizations. So actually earlier when internet started, it was confined to one region. For example, if you take this region, okay, like Bolivar, okay, so maybe only for Bolivar you have the internet connection, not anywhere else, not all places in Samarkand, only Bolivar. Okay, so regional university networks have been established, what you call it to be SuraNet. SuraNet is nothing but Southeastern Universities Research Association Network. Then afterwards, for computer science people, CSNet was being established. Okay, computer science network. Okay, and after that came NSFNet. NSFNet was being established during 1985 to 1995. Okay, NSFNet is nothing but National Science Foundation Network. Okay, so first ARPANET, then SURANET, then CSNet, then NSFNet. So this is how it has been established. First, for example, Bolivar, then Samarkand, then maybe connecting Registrar Square, everything, okay, like that, okay. Then from Samarkand to Kashkadaria or maybe Bukhara or something like that, and afterwards to Tashkent. So this is how it has been established, and the primary purpose is nothing but connecting the supercomputer centers. Okay, not computers within this region. Computers, connecting computers from here to the whole region. Okay, and the secondary purpose is nothing but to connect the regional networks. Okay, for example, Samarkand to Bukhara, Samarkand to Kashkadaria, Samarkand to Tashkent, but not out of Uzbekistan. Not out of Uzbekistan. Only the regional interest. Okay, right. So NSFNet, the backbone speed is around 56 kbps. Now we are enjoying 100 Mbps. 100 Mbps speed you are enjoying in your Wi-Fi. Yes, but now initially it was 56 kbps. Very small. Not even 2G. Not even 2G. Now we are having 5G and 6G. Not even 2G speed. And it was upgraded to 1.5 Mbps in 1988, the year when I was born. It was 1.5 Mbps. Then in 1991 it was upgraded to 45 Mbps. Okay, I'm talking about the regional network. I'm not talking about that particular computer alone. Okay, so that much speed only was there. And in 1988, networks like Canada or maybe France, they got connected to the NSFNet, National Science Foundation Network. And afterwards, 1990, ARPANET is actually limited the services, and NSFNet became the center of the internet. Okay, so earlier we have all this funding from the DoD, Department of Defense, that began in 1995, and we had communication protocols as well. For example, how computers can communicate, how we can use telephone protocol. Maybe for example, you earlier days when you use telephone, you dial 9, 8, 7, 6, and you do that. And afterwards, only after getting the ringing sound, okay, connection is established. Afterwards, you get the reply, hello. Then after some time only you will hear that. Maybe that person maybe would have said hello 5 seconds before. Only after that you will receive. Okay, so this is how you establish the telephone protocol, and whatever language you speak you will get the response even. So ARPANET, generally it was established with the transmission control protocol and internet protocol in 1982, and earlier there was no WAN, no wide area network, there were only local area network. Okay, so local area network means like cable connections that have been established. Okay, so earlier with the case of IP, Internet Protocol address, only 32-bit address or maybe 32-bit number was established in the IPv4 standard. There are two standards, IPv4 and IPv6. In IPv4 only 32-bit number was established, and generally it was established as the address. For example, 192.0.34.166. For example, you can check the IP address of your computer, 192.0.0.1.2, like that. Okay, 192.0.34.166. So in the diagram we can see the internet, and from that we are establishing a metropolitan area network connection type, static and dynamic type. Okay, and from there every server, all ports are open to the internet. Okay, so here we will have a public IP address 82, 88.34.223.22-26. Okay. So we have the header, the source, as well as the destination IP address. Okay. And we have the length of the data, how much data you have to specify. For example, the destination is another LAN, means the packet is sent across the gateway, okay, maybe like a bridge, okay, that connects more than one network. Okay, so this is how it goes with the IP function. I would explain this with the help of a diagram. Like we have network 1, okay, see over here network 1, and then we have network 2, okay, and then we have network 3. From source to the destination, it goes along different gateways. Source to gateway between network 1 and network 2, and gateway between network 2 and network 3. Okay, so from source to the destination, it passes across gateways to the destination. And similarly, with the case of this one, we have gateways LAN 1 and LAN 2. As I told you earlier, LAN was being established, local area network. From source to the gateway, gateway to the gateway, gateway to the destination. So this is how TCP acts, transmission control protocol. Okay, for example, when you dial the number, can I talk to you? Then you have to get the reply. Okay. Can I talk to you? Okay. Then you start speaking. Okay. For example, I am dealing business with you. Hello, how are you? Then you say, fine, sir. Thank you. How about you? You are asking me. Yes, I am also doing good. Let us do sheep business. Then I'm talking about this one. Okay, then only I'm sending the packet. Okay, then only I'm sending the data packet. Then you say, okay sir, I have got it. Then you got it, and maybe in return you say, here's the packet. Okay, and maybe if suppose information is not sent properly, okay, here's the recent packet I'm also giving you. Then you say, got it. Okay, and this is how information goes. Okay, for example, if suppose I am sending a packet, okay, or maybe you are sending a packet which I did not receive it, then I will try to resend it. Okay, then you will say, okay, I will got it. Okay, for example, let us take in the case I am trying to explain one particular concept. I was explaining, you are very busy drinking water. Okay, and afterwards, doctor, please tell me what you said. Then I will repeat once again. Then you will understand. Okay sir, I have got it. This is how communication goes. Okay, but there are some limitations of IP. No guarantee of packet delivery, which means packet can be dropped. Okay, and communication is one way, source to the destination, not from destination to source, only one way. Okay, so if you haven't received, that's a problem. Packet may be dropped. TCP, transmission control protocol, adds concept of a connection on the top of IP and provides guarantee that the packets have been delivered. So it provides the two-way full duplex from here to here and from there to here. Okay. So in the TCP, we have some port numbers also that I will be explaining. So port number is nothing but the application program on the destination computer. For example, if I am sending, okay, let us take in the case, there is an exam, exam, okay, and for example, I am saying, okay, you have to come at 8 o'clock in the morning. You have to come with full dress, full suit. Okay. For example, you are coming. You are coming. Your brother is coming. Let us take in the case. Your brother is coming, and your brother is wearing shirt and then shorts. He's not coming with suit. He's coming with shirt and shorts. Then I'm asking, who are you? You are saying, no, I am Maruf Beg. No, it cannot be, because Maruf Beg always wears suit, always wears shirt, pant, white shirt and black pant. Okay, like that he will come. But this guy, he comes with normal t-shirt and then shorts. How can it be? So that is nothing but port number. The port number is how you try to identify. Okay, this is Maruf Beg. Maruf Beg always wears white shirt and black pant. But this guy, he is wearing t-shirt and shorts. He cannot be Maruf Beg. So this is the port number. This is the identification number that I would recognize. Okay. So in the destination computer, you will have this application called as the port number, which has some standard meanings. For example, port 25 is normally used for email. Okay, SMTP, simple mail transmission protocol. Okay, so other port numbers are also, we have like FC, FS method, first come first served method. So for sending email, 25 is the port number. For the exam, you should become well dressed and you should have pen pencil. So this is how you try to identify. So here we would explain with the help of a diagram. We have host A and host B. From the mail server, it is going to send the port 25 messages, because for mail it is 25. Okay, to the transmission control protocol, and from there it is going to send the TCP messages to the internet protocol. From here we would be, in return, we would be having connection, okay, to the host B, mail client. Okay, this is server and this is client. From client to data, data to transmission control protocol. Okay, transmission control protocol 25 plus data to the IP. So from the client it goes like this: client, data, TCP. TCP, you are adding the data, data to IP, IP, TCP, data, again it is being passed, IP. Okay, so from there again transmission control protocol plus data. Okay, data to the server. Okay, so this is how the data is being passed. Data from TCP, you are adding the data, and from IP you are adding IP TCP data. Okay, and when you go to the IP you are going to remove the messages. You have TCP plus data, and from there you get the data. So from the client it enters the server, and from server it goes in response. Okay, so this is the user datagram protocol. Like we will be having like a client which is going to send the request, okay, as messages, and in response the server responds and sends a reply to the client. Okay, so in like TCP, it is going to build on IP and it is going to provide the port concept as well. But unlike TCP, it has no connection concept. Okay, just sending and then replying. Okay, no transmission guarantee as well. And if you compare UDP and TCP, it is lightweight. So UDP is faster for one-time messages. But if you say send multiple messages, means it will be a little bit slow. One-time messages, it will be fast. Okay, then we have the DNS, domain name service. So it is the phone book of the internet. So it is considered as a map between the host names and the IP address. So normally we can use DNS as for the purpose of using user datagram protocol for communication. The host names, for example, we will say www.google.com, www.samdu.uz. Okay, final label is actually the top level domain. So we have the generic domains to be .com, .org, okay, .net. Okay, but if you have the country code, for example, .uz, .us, .il. Okay, for example, Israel, like they have .il. Okay, maybe India, maybe .in. So how it explains? Okay. So domain name service is nothing like this one. From the domain name server, it is going to go to the internet. Okay, so we are going to get the DNS. I mean the from the node, it is going to send the HTTP request. Okay, from the domain name server, it is going to get the reply from for the query. Okay, so for the DNS server, which is connected to the internet, okay, to the Google, okay, we are sending a HTTP request. Okay, so when we send the DNS query, we get the DNS reply, and in response we get the HTTPS request. Okay, so here we have like for example www.google.com. So Google is nothing but a second level domain. Okay, so we have the host name plus domain name information, which is the fully qualified domain name. Okay, so we will have host name and domain name only fully, like a Google and then .com. Okay, So www is the host name. Okay, this is the host name. www.example.com is the fully qualified domain name. Okay, so www is the host name. Example is nothing but the domain name, and then we have .com. Okay, .com is nothing but the generic. Okay, right. So there is DNS lookup program also, where we have the command line access to the DNS, and generally if you are looking for the host name given the IP address, which is what you call to be the reverse lookup, right? So we have an analogy to the telephone network as well. So the address is nothing but the canonical IP address we are talking about, and here for the Windows we have IP config for finding the IP address, and then we have IP config slash display DNS, which is going to display the contents of the DNS resolver, and then IP is nothing but the internet protocol or maybe the telephone network. TCP is nothing but the transmission control protocol. So maybe you are going to call someone who's going to answer. Maybe you can have a conversation and then you can put the call, end the call. Okay. And then you have UDP, user datagram protocol, calling someone and then you can leave a message, text message. I will call you after something. You can send a message. Okay. And then DNS, domain name server for the directory assistance. So this is the higher level protocol I'm talking about. So okay, so this is the higher level protocol I'm talking about. So we will have like these are the layers: physical layer, medium access control layer, protocol adaptation layer, higher level application layer. Physical layer, medium access control layer, adaptation layer, application layer. Okay. So in the telephone analogy, we will have some TCP, which is going to initiate and terminate the phone call. For example, SMTP, simple mail transfer protocol for email. Then we have FTP, file transfer protocol, HTTP, hypertext transfer protocol. Okay, for the transfer of the web documents. Okay, so now we are going to discuss about WWW, World Wide Web. Okay, so we have support for the hypertext as well. For example, have you seen hypertext? Have you seen hypertext? Hypertext. For example, anywhere you can see www.google.com. If you move the cursor like this, it will immediately point like this. Clickable. Clickable link. Okay, so that is hypertext. Some text will be having some link. So if you move the cursor like this, then immediately the symbol will move like this, like a hand symbol. Okay, so that is hypertext. Okay, so communication through the hypertext transport protocol, and we have HTML, document representation using the hypertext markup language. Okay, so that is HTML. So here web is the collection of machines on the internet through the HTTP, and machines that access information on the web, you call it to be the web client. And web browser is a software used by the end user to access the web. Okay, so web browser, web client. Web browser is going to give information, and web client is going to access the information. Okay, so HTTP is based on the request response communication model. So client is going to send the request, server sends a response. Client sends a request. Okay, you are going to send a request and I am going to send a response. Okay, so HTTP is a stateless protocol. It doesn't have any state, and the protocol does not require the server to remember anything about the client between the requests. So this is the browser server interaction. So we have server side, web communication servlet to the database. Okay, then we have JSP, Java server pages. Okay, then the cache class, everything is being connected. Okay, so from the client side we have WAP browser, which is going to send communication to the web communication servlet. This is being interconnected. Okay, and from the JSP page it is going to send the response. So the browser uses the DNS to locate the IP address, and browser is going to open the TCP connection to the users as well, and it is going to open the connection to the server. Okay, browser is going to send the HTTP request, okay, hypertext transfer protocol request, and server is going to send the HTTP response. So browser sends HTTP request and server sends the HTTP response to browser over connection, and browser displays body of response in the client area of the browser window. So this is how the connection has been established. Okay, browser server interaction. That is the reason when you type www.google.com, it will take some time. Then it will load and it will give the result. So in that loading, these things happen. Request, response, okay, then displays the response. That's it. Right. So this is the Internet's telnet protocol for simulating the browser request. So we have connect $telnet www.example.org. Okay, 80 is the port number. Trying 192.0.34.166. It is nothing but the address, IP address. Okay, and then it will show connected to www.example.com. The IP address is this one, 192.0.34.166. Escape character is cap. Okay, so send request get HTTP, host is nothing but example.org, and receive response, you are getting the response. So at the time, date, everything has been displayed. Okay, so we have like start line, header fields, blank line, and optional body. The start line is nothing but get HTTP 1.1, where we have three parts: HTTP request method, request URI uniform resource identifier, and HTTP version. For URI, this is the syntax: scheme depend part. Okay, for example, in www.example.com, the scheme is nothing but this HTTP. This is the scheme. Okay, and request URI is nothing but the portion of the requested URI that follows the host name. Okay, host name is nothing but this www. Okay, right. So we have like URN, okay, uniform resource name, that is going to identify resources with the unique names. So we have the scheme to be URN. Then we have get, post, and head. Okay, get is nothing but getting. Okay, so used if link is clicked. We are giving input, link, clicking the link or address typed in the browser. Okay, no body in request with the get method. Okay, and then post, used when submit button is clicked on a form. Finally, after that submit you click no. Okay, so that is the post method. Form information contained in the body of request, and then head, request that only header fields be written in response. Okay, so these are the common header files. We have a host, nothing but the host name from the URL. User agent, it is the browser sending request. Accept, we have MIME, multipurpose internet mail extension, and then connection after the request response, and then content type. Okay, so it is nothing but the meme type of the post body. Content length, okay, bytes in the body, and then referrer, it is nothing but the URL of the document which is containing that link, that hyperlink for the supplied URL. Finally, we end with the client caching. So cache is nothing but the local copy of information obtained from some other source. For example, if you are searching maybe like Maruf Bek, you type in Google. Okay, then okay, you will get some search result. Okay, sometimes before 2 months, maybe in the ministry they have published information about you, that also come similar cache, it will display. Have you seen that? For example, if you type Maruf Beg, you will get the search result. But you can say for one particular link, you will have cache. Cache is nothing but some information stored in somewhere. That also comes here. Okay. So this is the local copy of information obtained from some other source. Most web browsers use cache to store requested resources, so that subsequent requests to the same resource will not necessarily require the HTTP request. Even Without the internet connection, you can see the cache. That is the greatest advantage. Okay. So this is the cache. Okay. Like we have the browser. Okay. From the client we have the browser. Server we have the web server. So HTTP request for the image we are sending, and in response we are getting the HTTP response containing the image, and then we are going to store the image. So this one it is going to store. Maybe after 2 months or 3 months, if we are trying to access it, it will show. Marufbek, before 2 months, the information is this one. It will show. Okay, so that is the client cache. So from the browser, after maybe 2 months or 3 months, okay, you are sending. I need that image again. So from the storage, it is going to access the image. Okay, did you understand? Right. So this is the thing. HTTP request for image. So HTTP response containing the image. Browser says I need that image again. So from that, from the storage, it is going to get it. Okay. And also, or maybe I need that image means you can also get image from here, or you can get it from the web server. Web server currently you can do it. Storage maybe after 2 months, after 3 months. Right. So this is the independent work. An introduction to PHP, using PHP variables, program control, and built-in functions. So you are going to do it. I'm going to create a Google Classroom. You are going to join. You are going to submit the independent works. As usual, you are going to submit each independent work and with the open-ended project.